Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Okay, today we are looking at this question. We are still under momentum. It says, what is meant by a closed stroke isolated system? Okay, that's the question. But here, um, before we go to the question, the first question would be, what is a system when it comes to mechanics? A system actually is a group of are particles or objects which are under study or which are under observation. So anything can become a system provided our focus is on it. So that's the system. So every time we mention the system, you must expect objects or particles which we are studying, which are under observation or which are under study. Okay. Then there is another term which we are going to use in this definition: external force. Yes, we have external and internal forces. What are external forces? External forces are those which are acting from outside the body. Actually, most of the forces which are going to put under consideration here are going to be external. The applied force, the normal force, the friction force, all those ones are external forces. Internal forces actually act from within the body, and we are not going to see them a lot. These include the shearing forces, kinetic energy of the particles. So our focus throughout mechanics is going to be on external forces, though some of the external forces can affect the internal forces, but that's what we are going to be looking at. Now back to the question. The question says, what is meant by a closed or isolated system? Okay. A closed or isolated system is a system on which no external forces are acting. Okay? Because we don't have influence on internal forces, so all our jobs are going to be on external forces. So when you talk about closed or isolated system, we mean a system on which no external forces are acting. Yeah, so that is it. A system on which the net external force is zero. Okay, or a system on which there is no external force. Okay, let us come to the next question. It says, state the principle of conservation of linear momentum. Yeah, momentum, which is mass times velocity, which is a vector quantity. We are now coming to almost the end of it. There is a principle of conservation of linear momentum, and how does it state? It states that the total linear momentum of an isolated system is conserved or remains constant. So that is it. Now let us explore the meaning of this statement. What does it say? Let us explore it. Total linear momentum of an isolated system remains constant. So let us assume that we have a system where external forces don't have influence. Okay? And we know that we are having two objects A and B, having masses MA and MB, moving at velocity VA I and VBI initially. Okay, that's what we have. So this information we have here gives us what we call momentum. You have to remember that momentum, which is P, so if we have two objects, momentum of A, we can call it PA. And because it's before collision, we can call it PAI. And you have another momentum of the other object, which is B, which is going to be called PB. And because it's before collision, we're going to go PBI. That's before collision. So according to this statement, this total momentum before collision is going to be equal to total momentum after collision. That's what we call conservation. Conservation means that it remains the same. So here we have the equation saying PAI plus PBI giving you what? PAF plus PBF. So in other words, this is the total momentum after impact, after collision or explosion. So according to this statement, this total momentum is equal to this. It is conserved. The explosion or collision did not change it. Okay? From here, then we have to know what is PAI. PAI is MA VAI. Remember, P is equal to MV. Momentum is equal to MV. So, what is PBI? PBI is MB VBI. Okay, and that one is equal to, okay, PAF, what is it? It's going to be MA VAF plus MB VBF. And this equation here is paramount. It's a very important equation. Actually, it is the equation which represents the principle of conservation of linear momentum.